Oh, hi! I'm actually in the middle of organizing this closet. I got some bins, and now I'm just making tags so I know what's in each bin. Naming and categorizing items is a great way to keep yourself organized. And actually, we're going to be naming and categorizing some items today. Let's get into it. So you may recall that an angle is formed when two rays intersect at a common vertex, like this. Let's give this angle a name. First, this is an angle, so we use this symbol, which looks like a mini angle itself, to indicate that we are talking about an angle, as opposed to a line or a ray. Then we can use the letter representing the vertex, which is A. But what happens when I have a bunch of different rays all intersecting at the same point? How can I name this angle A if this might also be angle A? Or this one? Or even this one? How can we name this angle so that it's clear we're referring to the angle formed by rays AB and AC? To be clear about which angle we're referring to, we can use 3 points. A point on one side of the angle, then the vertex, and then a point on the other side of the angle. So this angle can be called angle BAC or angle CAB. Both represent the same angle. What about calling it angle BCA? Does that name represent the same angle? Not quite. In angle names, the middle letter always represents the vertex of the angle. In angle BCA, the vertex is C, which means this name refers to the angle formed by rays CB and CA, a completely different angle from the one formed by AB and AC. In addition to naming angles, we can also classify them by their size. Take a look at this angle. Can you recall the term we used to classify this angle? This is a right angle because it measures exactly 90 degrees. Right angles are indicated on a diagram with a small square at the vertex of the angle. This angle measure is smaller than the right angle. How would we classify it? This is an acute angle because it measures less than 90 degrees. This angle measure is larger than the right angle. What type of angle is larger than a right angle? An obtuse angle is an angle that measures greater than 90 degrees and less than 180 degrees. There is also a specific name for an angle that measures exactly 180 degrees. It's called a straight angle because it makes a straight line. Take a look back at angle BAC. Would you classify it as an acute, obtuse, right, or straight angle? That's right, it's acute. We can tell because the actual angle measure is notated here. It's 50 degrees, which is less than 90 degrees. We can also imagine comparing angle BAC to the corner of a piece of paper, which is a right angle, and see that this angle is smaller, so it must be acute. Let's name and classify a couple more angles. Pause now and name the 4 colored angles indicated on the diagrams, writing 2 different names for each angle. Then, classify each angle by its size. Let's see how you did. This angle could be called angle DAE or angle EAD. As long as the vertex is in the middle, we can name it in either order. This symbol in the angle tells us that it is a right angle. See how it forms a perfect square corner? This angle could be called angle BAE or angle EAB, and it is obtuse. Why? Because it's bigger than a right angle. we can imagine a right angle fitting inside it with room to spare. Moving over to the other diagram, this angle could be called angle WXV or angle VXW, and it is a straight angle. The sides form a perfectly straight line, so we know its measure is 180 degrees. And finally, this angle could be called angle YXZ or angle ZXY, and it is acute since it's smaller than a right angle. Great work! Acute, obtuse, and right are terms we use to describe one single angle, but sometimes we need to consider a pair of two angles. When talking about angle pairs, we have some additional terms that we can use to describe the relationship between them. One way to describe the relationship is their location in space compared to each other. Two angles are adjacent if they share a side and a vertex, or non-adjacent if they do not share a side or vertex. Angles that share only a vertex, like these, or only a side, like these, would be considered non-adjacent, since they have to share both a side and a vertex. In addition to where they are in space, we can also classify angle pairs based on how their sizes relate to each other. Two angles are complementary if their measures sum to 90 degrees. When complementary angles are adjacent, they form a right angle. Two angles are supplementary if their measures sum to 180 degrees. When supplementary angles are adjacent, they form a straight line. Angle pairs that are both supplementary and adjacent are called linear pairs, because they're a pair of angles that form a straight line with their non-shared rays. Let's finish up today by taking a look at some pairs of angles and describing their relationships. First, we have angle EAB and angle BAC. Which terms describe the relationship between angle EAB and angle BAC? Are they adjacent? They are. They share this vertex, A, and this side, ray AB. And they make a straight line, which we know measures 180 degrees, so they must be supplementary. Since these are both supplementary and adjacent, they are also a linear pair. Pause now and classify these angle pairs. Let's see how you did. Angle BAC and angle YXW do not share a vertex or a side, so they are non-adjacent. Angle BAC is 50 degrees and angle YXW is 40 degrees, so their sum is 90 degrees, making them complementary. Let's classify angles EAD and ZXW next. First, they do not share a side or vertex, so they are non-adjacent. Next, we can see the right angle symbol in both angle EAD and angle ZXW, so they are both right angles. Right angles are 90 degrees, and two 90-degree angles sum to 180 degrees, making these supplementary. Are these a linear pair? No, they have to be both supplementary and adjacent to be called a linear pair. What about angle BAC and angle EAD? These angles share a vertex, but not a side, making them non-adjacent. Angle BAC measures 50 degrees, and this box in the vertex tells me that angle EAD is a right angle, which means it measures 90 degrees. What's the sum of these two angle measures? 50 plus 90 makes 140. Since they don't add up to 90, they're not complementary, and since they don't add up to 180, they're not supplementary either. And finally, we can see that angle ZXY and angle YXW are adjacent since they share a side and a vertex. This symbol tells us this is a right angle, so ZXY and YXW create a right angle, which means they're complementary. Great work! All right, today we learned how to name angles using 3 points, a point on one side, the vertex, and a point on the other side. We also learned how to classify angles by their size and angle pairs by their relationship to each other. When you finish these guided notes, you can move on to practice levels 1 and 2. And remember, math is everywhere. Keep exploring.
Hey, hey.